In my previous video, I have explained to you certain tests need to be performed on the aggregate if those tests and their values are complying to the requirement of the specification of Superpave, then we are considering those aggregate very suitable. And all those tests have proved that whatever source of aggregate we have used, their values are fully complying to the specification requirement. When that phase is finished, now our next procedure start, where we are going to form the design aggregate structure. Actually, this design aggregate structure, simply you can say that skeleton. What do you mean by skeleton? Okay. We have combined our coarse aggregate, we have combined our fine aggregate along with filler. When all these aggregates are going to combine with each other in such a way that they are going to form a one skeleton where we have proper formation of combined grading clear? We can say that minimum widths. When such type of the skeleton is formed, over here I would like to tell you, load of traffic is bear by aggregate. You see, keep this in mind. Binder is just going to combine them to the aggregate, and all the load of the traffic is being sustained by the aggregate. When such type of the combination we have obtained, where it is going to resist the loading, this structure going to resist the loading. It means when load is being exerted on this one, it is not going to disintegrate. It is not going to leave its position. It is going to sustain the load and distribute the load. When such thing is happening, so this type of the combination of aggregate which you have made is known as our design aggregate structure. But directly I cannot go to the design aggregate structure, that how we are going to form it. Before making this design aggregate structure for the Superpave, there are certain terms which need to be defined and explained very well. And those are, first of all, gradation. The first part for the development of the design aggregate structure is the gradation. After this gradation, we are going to define maximum density line. For the aggregate. Third one, maximum size of aggregate. Fourth one, nominal maximum size of the aggregate. Fifth one, control points. Primary control sieve. Seventh one, restricted zone. All these are related further with the aggregate. Because gradation is performed on the aggregate, how the maximum density line is going to affect, what are the maximum size of the aggregate, what are the nominal maximum size, what is the control point, what is the primary control sieve, PCS. Sometimes we are also defining a secondary control sieve, but over here for the time being it is not required. And next one is the restricted zone. So all this type of material written over here, it is very necessary to explain. We will go on explaining each and every of these items for your understanding. When the broad concept of your understanding will be developed in mind, then we will be able to design the design aggregate structure. Here, just for introduction, I will tell you, like in Marshall, we were making one structure. Over here, when we are going to develop the Superpave mix design, one is not sufficient. We will have to make either 3 or more than 3 structure. From those 3 or more than 3, we will see that which one is going to accept more accurate way the criteria set by the Superpave specification. It was just introduction. Now I will go on explaining each and every of these items in my coming video. Thank you for seeing this.